Hello everyone, welcome back. Today our topic is quadrilaterals, which are nothing but the rectilinear figures just like parallelogram, rectangle, rhombus, square, okay, trapezium also. So we are going to learn them one by one, okay. Now you already have some basic idea about quadrilateral. So quadrilateral is nothing but a four-sided polygon, okay, where it has four vertices, two opposite sides of pair, two opposite angles, okay. Adjacent sides also, you know, this AB and BD here are the adjacent sides, and you are also aware of the diagonal, the opposite vertices. When we join them, the line segment is called the diagonal. Alright. And now some special kind of quadrilaterals also you have learned so far. Okay. Parallelogram is nothing but pair of opposite sides are parallel. Rectangle, one angle is right angle in a parallelogram. Rhombus, all sides are equal in a parallelogram. Square, it has both combination, all sides are equal, all angles are equal. Okay. Kite is a special quadrilateral where adjacent sides are equal. And trapezium, it has one and only one pair of opposite sides are parallel. Okay. Now we'll learn the first theorem. Okay. This is nothing but the sum of the four angles in quadrilateral is 360, which is very easy to prove. So here if you just join the diagonal, okay, then the diagonal divides the quadrilateral in two equal parts. I mean two parts, okay, two triangles. So what I can say, in triangle ADC, okay, what can I say about this angle? Angle 1, angle 2 and angle 3. The sum of these three angles is angle 1 plus angle 2 plus angle 3 equals to 180 degree. We already learned that angle sum property of the triangle, right? Now similarly we have one more triangle, which is triangle, yes, triangle ABC. So here if I just write this as 4, 5 and 6. So what can I say? Angle 4 plus angle 5 plus angle 6 equals 180 degree, right? Now if I'll add them, okay. So adding 1 and 2. So what do we get? Adding 1 and 2. See, whenever you add, write this, I mean, in a proper manner so that you can write them, add the left hand side and right hand side to get the desired result. So angle 1 plus angle 2 plus angle 3 plus angle 4, 5 and 6 equals 180 plus 180. Correct. Now tell me, what is angle 1 plus 4 and angle 2 plus 6? This is angle A. So angle 1 plus angle 4 is angle A. Angle 2 plus angle 6 is C. I'll write 5 as B. Angle B plus angle C plus angle D equals 360. So that is nothing but the sum of all angles in the quadrilateral is 360. Hence it is proved, right? I hope you understood this. Very easy theorem, correct? Alright. Now let's take one question based on this. Now here we are given a quadrilateral and the angles are in the ratio 3 to 5 to 9 to 13, and we have to find all the angles of the quadrilateral. So let the proportionality constant be x. Okay, so what I can say, the angles are 3x plus 5x plus 9x plus 13x. I can add all the angles, okay, and that sum is 360. So the theorem says that angle sum of quadrilateral is 360. We just learned this theorem, right? Now, when I simplify this by adding those, so what do we get? So, on simplifying this, we'll get 30x equals to 360, and so x is equals to 12. Now, on putting x equals to 12, we'll get all the angles. So, first angle is nothing but 3x, which is 3 times 12 is 36 degree. Okay. Second angle is nothing but 5x, 3 times 12, 5 times 12, which is 60 degree. Third is 9x, which is 9 times 12, which is 108 degree. And the fourth angle is 13x, which is equals to 13 times 12, 156 degree. So we found all the angles of the quadrilateral. Alright. Let's move on to the next theorem. Now here the theorem is saying the diagonal of a parallelogram divides it into two congruent triangles. So given that ABCD is a parallelogram, AC is the diagonal, and which forms two triangles here, triangle ADC and triangle ABC. We have to prove that they both are congruent. So let's prove it. Okay. So what can I say about this angle and this angle? Yes, they are equal. Why? Because, so let me write it. In triangle ACD and triangle CAB. Okay. What can I say? Angle ACD equals angle CAB. Correct? Alternate angles. Very good. Alright. Then AC is common. And which other two angles are equal? Tell me. Do we have any other angles equal? If I'll talk about this parallel sides, we already know that opposite sides are parallel for a parallelogram, right? So I can say this angle equals to this angle, correct? So angle DAC equals angle ACB, correct? Again alternate angles. So what do we get now? Which two triangles are congruent? Yes, triangle ACD is congruent to triangle CAB. That only we have to prove. That is done. Now we can prove so many results based on this. Okay, we proved that these two triangles are congruent. Now based on that we can prove all these theorems. Okay, so first is what? In a parallelogram opposite sides are equal. Now here from CPCT I can prove that, correct? AB is equals to CD and BC equals to AD. So hence it is proved. Now converse of that, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Alright. See, proofs are not that much important, but these results are very important that we are going to use them to solve the questions based on that. Alright. Okay. Next is in a parallelogram opposite angles are equal. Again by CPCT. You can prove that here angle B is congruent to angle D, and similarly you can say angle A is congruent to angle C. And now converse of that, in a quadrilateral of each pair of opposite angles is equal, then it is a parallelogram. Remember this, okay? This is very much important. Next is the diagonal of a parallelogram bisect each other. Okay. And the next theorem, converse of that. If the diagonals of quadrilateral bisect each other, then it is a parallelogram. Alright. So remember all these statements. We are going to use them to solve many questions. Alright. Now let's move on to questions. Okay. Now very first one. Here ABCD is a parallelogram and AB is given as 20. This is 20. AD is 12. The bisector of angle A meets CD. So this is the bisector, means what, these two angles are equal. Okay. And we have to find the length of CF. This length we have to find. Alright. Okay. Now what to do? See, these two angles are equal. Correct. Angle DA, what I can say, DAE and angle BAF. Okay, so let me write this. See this both angle where I keep X. Okay, so let's say this angle DAE equals angle BAF. Okay, is equals to X. This is given. Okay, bisector is given. Why? Because AF is the bisector. Let me write this. AF is the bisector of A. Alright. Now, what else? These are parallels, correct? So, what can I say? This angle and this angle. Can I say they are equal? Yes. So, let me write this angle DAE equals angle EFC and both are X, correct? Alright. Now, what can I say for this triangle ABF? Okay, ABF. So, see, these two angles are equal. Means what? AB is equals to BF, correct? Yes. AB, this implies that AB is equals to BF. Why? Because opposite angles, these two angles, opposite sides are equal angles, right? Opposite sides of equal angles are equal. Are equal. Correct? Yes. Now, can you find it out? It is very easy. See, this we already learned that opposite sides of a parallelogram are equal. So, what can I say about BC? Yes, it is 12. And now we have to find CF. We already know how much is BF. Therefore, AB is equals to BF. AB is given. Tell me how much? 20 centimeters. So, therefore, CF is equals to BF minus BC, and that is what, 20 minus 12. So CF is equals to 8 centimeter. Sorted, right? Great. Here ABCD is a parallelogram and we have to prove three results. Okay. First is AP bisects angle A. This we have to prove. Now see, when I want to prove AP bisects angle A, that means I have to prove these two angles are congruent. Okay, we'll do it. Same way BP bisects angle B, means I have to prove that these two angles are congruent. And also I have to prove this result. DAP, here this angle plus this angle is equals to this angle. Alright, let's do it. Now, as shown in the figure, what can I say for these two triangles? Which triangle? Triangle ADP and triangle BCP. What can I say? See, I already know that AD is equals to BC, correct? AD is equals to BC, opposite sides of parallelogram, correct? Parallelogram. Now, what can I say? See here, this is given to us. DP is equals to PC. That is also given. This is given. And now, see, these two are same. Means what? This angle and this angle are equal. Same way, what can I say? This angle and this angle are also equal. Correct? So, now, automatically the remaining angle, this and these are equal, correct? So what can I say? Angle D equals angle C. Okay, and hence by ASA, what can I? Triangle ADP is congruent to triangle BCP. Okay, ASA congruency. Alright, now hence what can I say? See, these two angles are congruent, correct? Angle DAP is congruent to angle CBP, right? But they are supplementary angles, right? And whole angle, angle A and angle B are supplementary angles, and these two parts are equal. So what can I say? Other two parts are also equal. So angle DAB plus angle CBP, sorry, CBA, they are 180, and half of them are same, right? So what can I say? The remaining half of them are also same. So angle PAB equals angle PBA. Okay. Hence, therefore, AP is the bisector of angle A, and similarly BP is the bisector of angle B. Alright. Now, see, here we already proved that from this half of this, okay, half of that is PAB and PBA are same, so we can say that angle DAP plus angle BCP equals angle APB, correct? Why? Because see, this plus this equals to angle P, but they both are same, these both are same, so I can replace this, right? So hence we proved it. Alright, great. Now we have to show that the diagonal of a rhombus are perpendicular to each other. Okay, we have to prove. What we have to prove? BD perpendicular to AC. Now for that, here ABCD is a rhombus which is given to us. Okay, alright. Now see, for that, okay, I'll try to prove that these two angles are 90 degree, so that I can prove that BD is perpendicular to AC. Now proving this to 90 degree, I'll try to prove triangle DCO and triangle BCO are congruent. Okay, let's try that. Now here, what can I say? DC is equals to BC, adjacent sides of rhombus, correct? Now also OC is common, correct? OC is equals to OC, and we already know that diagonal of parallelogram bisects each other. Means what? OD is equals to OB. Diagonal of parallelogram bisects each other, correct? So what can I say? These two triangles are congruent. DCO is congruent to BCO. We use which criteria? Yes, SSS. And hence what can I say? By CPCT, angle COD is equals to angle COB, correct? But they are linear pair. But they are linear pair angles, correct? So what can I say? They both are 90 degree. Therefore angle COD equals angle COB equals to 90 degree. Hence what can I say? Yes, BD is perpendicular to AC. We proved it. Great. Alright, now here in this question, ABC is the isosceles triangle which is given, okay, where AB equals to AC and AD is the bisector of angle PAC, which is the exterior angle, okay. So that means these two angles are equal, alright, okay, and CD is parallel to AB. CD, this is parallel to AB. So this is also given. And now we have to prove that this two angles equal. Which two? DAC, this, and BCA, this. That means we have to prove that AD parallel to BC. And once we prove that, we have to prove that ABCD is a parallelogram. So let's do it. Okay. Now see. First of all, this two are, this is isosceles triangle. So what can I say? See, angle 1 equals to angle 1. Can I say that? Yes, I can. And I can say that angle 2 equals to angle 2. Correct? Because AD is the bisector. Right. Okay. Now, see. First of all, what can I say? Angle PAC. Okay. Angle PAC is equals to angle B plus angle C of triangle ABC. Why? Because exterior angle property, correct? Angle property. So what it says, this exterior angle is sum of the far interior angles. So we already know that. Now therefore here, if I write 1 and 2, so that is so easy to write it. See, 2 times angle 2 is equals to angle 1 plus angle 1. Now from this, what can I say? Angle 2 equals to angle 1. Now look at here. This equals to this means what? They are alternate angles, right? So this implies that, what can I say? Angle DAC equals angle ACB or BAC. Can I say that? BCA, sorry. See, we have to prove this and we proved it, right? We proved it. And now they are alternate angles. So what can I say up from this? AD is parallel to BC. We already proved it. We proved it, right? Now, why? Because here you have to write these are alternate angles, okay? These are alternate angles. Okay, now see, we already learned that theorem that if both the opposite pairs of the opposite pair of quadrilateral are parallel, then it is a parallelogram. Now CD is parallel to AB is already given. Okay, CD is parallel to AB given. So what can I say? Yes, it is proved. ABCD is the parallelogram. Correct? Using the theorem. Okay, you have to write the statement of the theorem. Alright? Okay, great. Very interesting question. Okay, two parallel lines L and N, okay, are intersect by the transversal P. Now we have to show that the quadrilateral formed by the bisectors of interior angles is a rectangle. Means what? Let's say this is C here. Okay, this is point C. This is point D. Let's say this point is R. Okay, now see what is given first of all. Let's write it properly. Okay, the given thing is L is parallel to M and P is the transversal. Okay, one more thing is given. AB is the bisector of angle PAC. Okay, same way CP is the bisector of angle. Tell me which angle? ACB. Correct. ACQ. ACQ. Right. Also, AD is the bisector of. See, we are given all four bisector now, so we have to write all of them. Huh? AD is the bisector of which angle? Yes, angle SAC. And one more, CD is the bisector of angle ACR. Now after writing this, now almost half of the question done. So what we have to prove now? To prove ABCD. Okay, ABCD is a rectangle. Is a rectangle. Okay. All right. Now see, what can I say about this whole angle A and this whole angle C? Correct. So angle PAC plus angle ACQ equals to 180. Supplementary angles. Correct. Supplementary angles, and now half of them. So half of angle PAC plus half of angle ACQ is equals to 90 degree. I am dividing all of them by 2. Now half of PAC is, I am interested in this angle. So what can I say? Angle BAC, correct? Angle BAC plus angle ACB is equals to 90. Now in this triangle ABC, sum of this two is 90. So other angle is also 90. So what can I say? Let me write it here. Therefore, angle ABC is equals to 90 degree. Correct? And similarly, we can prove for angle D also. Right? So similarly, angle ADC is equals to 90 degree. Now we already learned the theorem that if opposite angles of a quadrilateral are equal, then it is a parallelogram. So here this opposite angle A and B are, B and D are equal, and they are 90 degree also. So therefore, what can I say? ABCD is a parallelogram also and a rectangle. A rectangle, right? We use that theorem, converse. Okay, great. Now this is almost similar question as the previous one. Okay, now we have to show that the bisector of angles of a parallelogram form a rectangle. Means what? PQRS here is a rectangle that we have to prove. So this is almost same. Okay, what can I say? See here, this angle, okay, and this angle. So see, I can just label them. Okay, 1, 2, 3, 4. Then it is going to be super easy for me. This is 1. So this is also 1. This is 2. This is 2. 3, or I can say 1 only because the opposite angles are equal. And this is also 2 and 2. Now I know that. See, I'm directly writing this. Okay, you have to write this just like the previous question. DR is the bisector of angle D. then AP is the bisector of angle A, and so on. Okay, complete this what is given to you, and now what you have to prove? We have to prove that PQRS is a rectangle. So you have to write that. And now directly I am writing the proof. Okay, so what can I say? Angle A plus angle D is equals to 180 degree. We know that supplementary angles. Okay. So what can I say? 2 times angle 1 plus 2 times angle 2 is equals to 180, and hence I'll get angle 1 plus angle 2 is equals to 90. Now in this triangle, I'm talking about this triangle ADS. These two are adding up to 90 degree, so that automatically third angle is 90 degree. So that gives me angle DSA is equals to 90 degree. Okay. And therefore, what can I say about its vertical opposite angle? Yes, this is also 90. So angle PSR is equals to 90 degree. So we proved one angle is 90 degree here. Similarly, I can prove this angle also 90 degree. So you have to simply write that. Similarly, what can I say? Angle CQB is equals to 90, and therefore angle PQR is 90. Okay. Just look at this figure. Okay, I am proving this to our 90 first of all by using the supplementary angles, and then vertical opposite angles. Okay, they are vertically opposite. Let me write it here. Vertically opposite angles. Okay, so we can write similarly, and now these two opposite angles of a quadrilateral are equal. So PQRS is the parallelogram, and they are 90 degrees, so it is a rectangle. So I'll write this. Therefore, quadrilateral PQRS is a parallelogram and it is a rectangle. Alright, I hope you get it. Okay, great. Now, very interesting question. Okay, see, ABCD is a trapezium which is given to us, and what I have to prove? We have to prove 4 results. Okay, angle A is congruent to angle B. Okay, these are adjacent angles which we have to prove they are congruent. Alright, then angle C equals to angle D. Again, they are adjacent angles of the trapezium which we have to prove they are equal. Okay, then we have to prove that uh, triangle ABC here, this triangle small ABC, this one. Okay, this triangle is congruent to this triangle. This we have to prove. Alright, and also we have to prove the diagonal of this trapezium are equal. Alright, now to prove all of these results we have to take a construction. What construction are we taking? We are extending the AB, okay, side AB, okay, and we are taking a parallel CE which is parallel to AD. Okay, we are taking that, which they both intersect here in A. Alright, so this is the construction which we have taken. Now after this construction, what can I say? See, this AD equals to CE, correct? We have taken this construction. So let me write it. Okay, AD is parallel to CE, and AD is equals to CE based on the construction. Okay, alright. Now ABCD is a parallelogram. ABCE is a ADCE is a parallelogram. Okay, ADCE is the parallelogram. Alright. Now what can I say? AD is equals to BC. These two are given. So automatically BC is equals to CE then, correct? AD is equals to BC. This is given. Therefore, what can I say? BC is equals to C. Now, again we'll number this, okay? See, I have to prove this angle 1 equals to angle 2 and angle 3 equals to angle 4. This I have to prove now. So I'm just numbering them. Now, see, here, angle 4 is angle 4 here, parallelogram. Now, these two are same, okay, in this triangle BCE. This is 4, so this is also 4. Can I say that? Yes, I can. So now see from the figure, okay, from figure, what can I say? Angle 1 plus angle 4 equals 180. Also angle 2. These are adjacent angles, okay. And angle 2 plus angle 4 equals 180, linear pair. Correct? Now, yes, very smart. Angle 1 equals to angle 2. So, we prove that angle A is equal to angle B. This one we have to prove. Correct? Now, see. Can I say 4 equals to 3 here? Yes, I can. So, angle 4 equals to angle 3. Angle 3. Alternate angles. This and this. Correct? Alternate angles. Now, what we already know, here, this two, okay. See this 4 I am talking about angle. Let me write here, EBC equals angle BCD. Okay, I'm talking about these two alternate angles. So angle 3 equals to 4, but as angle 3 is angle C, so and angle 4 is angle D, so therefore angle D equals to angle C in this trapezium, and that we already proved, right? Great. Now one more thing, what can I prove? See, if I talk about these two triangles, okay, I'm taking triangle ABD and triangle ABC. I can say AB equals to AB, right? AB equals AB. Also what we have, angle 1 equals to angle 2. Angle 1 equals to angle 2. We just proved that. And also what I have, yes, AD equals to BC. This is given. AD equals to BC given. So by SAS, what can I say? These two triangles are congruent. So you have to write that, okay? Just complete writing this by SAS, okay? And by CPCT, what we can say? Diagonal AC equals to diagonal BD here. AC to BD, okay? From this, you'll get that. Alright? So, I hope that you understood all the questions which I have taken here, okay? If you have done along with me, then you are really amazing. If you could not have done along with me, then watch the video again, pause the video, do it your own, okay? If you have any doubt, you are always welcome to ask your doubts in the comment box. Let me know how did you like this session, okay? And I'm taking the midpoint theorem in the next session. Alright? Thank you for watching this video.